All right, so I'm still troubleshooting with a new computer, new OBS and everything like that. So hopefully everything works online. Remember, we are on Piazza and on YouTube, so if you have any questions, please post there. Last week we left off talking about strings in C, and then I briefly, reviewed what we introduced, setting strings and basic string manipulation in Java, showing you how easy it is, right? In C, a string is just a character array, but it's a character array where it has to be null terminated. So if I've got an array of 10 characters, I want to hold a string of 10 characters, I need an array of length 11 because I need to put that null terminating character at the end, right? Now in Java, you don't have any of those concerns. In Java, a string is a built-in type, right? It's not really a first-class citizen, but it is built into the standard language library. You also have a string library in that you have all these functions that you can call when you've got a string. However, you don't have null terminating characters at all, right? You don't need them because it's built into the language, and so it's a lot easier to use these things. However, in Java, it is immutable. In other words, once you create a string, you cannot change it, right? And that's where we left off last time. Let me go ahead and show you what I mean by that. Hopefully this is big enough for everybody in the back, but if not, I'll go ahead and zoom in. So first of all, string library, right? The string library is built into the string class. So if I've got this string s here, right? I can output it, of course, and it'll print out hello. But I've also got dozens upon dozens of different functions that I can call, methods that I can call on that string to manipulate the string. So I can get a character at a particular index, right? Get the first character, get the second character. Let's see that in action. I want to get the first character and print it out. System.out.println s.character at 0. Well, what's the character at 0 for s? It's going to be a capital H, right? If you want the fourth character, index 3, remember it's indexed by 0 just like any other array. You can do that as well. What happens if I try to get the 30th character? What do you think? It's going to be an out of bounds exception, right? So you can't do that, right? But there are dozens upon dozens of other methods that you can call to manipulate and change a string, but a string is immutable. For example, if I wanted to convert all this to uppercase letters, to uppercase, I can do that, right? But is that changing s? Let's find out. I'm going to convert everything to uppercase, so it's going to be uppercase H-E-L-L-O, all uppercase, and we're going to try to print it out. No change. Why? Because the original string s is immutable. Yes, you can call this function on it, but it returns a new string that you have to capture, and that's what you have to print. So string stu, I guess, and I will show you that the original string is unchanged, but the new string u is hello, all uppercase now. Right? So all of these functions do not change the string. They only give you, they take the contents of the string, manipulate them, change them, and then create a new string, and that's what it gives to you. So you actually have to capture those return values there. Right? That's how you deal with immutability in Java and strings in Java. Okay? Questions so far? All right. Well, you can use, as we talked about last time, you can use the assignment operator. You can use the concatenation operator. You do not need to call something like strcpy. You do not need to call strcat. Right? It's taken care of for you, null terminating characters, etc., etc. You can find the length of a string. The .length method gives you the length of a string. And again, counting the null terminating character, not counting the null terminating character, there is no null terminating character. So it's not even a relevant question, right? The number of characters in it is its length. You can iterate over iterate over each character in a string easily. All you have to do is set up a for loop, right? I want to iterate over each character in the string hello. For int I equals 0, I is less than s dot length, right? I plus plus, and then I can get the character, char, c, is equal to s dot character at, get the ith character, and then print it out. System.out.println c. And you can see that it's HELLO, each individual character. Okay? Once you pull the character out, if you want to build a new string, you can do that as well. Okay? You can use mutable strings in Java, right? Using something called a string builder. There's also a string buffer, which is a little bit older school Java. So string builder is what you should use if you want to build a string. Okay? A string builder is a mutable version of a string. Mutable, in other words, it's changeable, right? Its contents, you can actually change the contents of a string builder and then manipulate it, right? So let me go ahead and come over here and show you how it works. String builder, SB, is equal to new string builder. Right now, that's an empty string. What you can do is you can append to that string. So sb.append. Right? Append is like concatenate. It just adds it to the end. Hello. Right here, I'll go with hello. And then sb.append space. And then sb.append world. But I'm going to show you something cool here. This is called a fluent pattern, I think it is. The append function actually returns the string builder that you're manipulating. So, you know, I'm going sb.append, sb.append, sb.append. What you can do is, oops, there we go. You can actually just chain these all together. sb.append, .append, .append, if you want to. And it's called a fluent pattern. You can do it one way or the other way. It doesn't matter, right? This is not an advanced object-oriented programming kind of thing, but it's a fluent pattern that you don't have to write sb dot, sb dot, sb dot every single time. Now, what are the contents of this string right now? Or this string builder, I should say. System.out.println. If I were to print sb, what are the contents? Hello world. Right? What I want to do is I want to correct this. I want to capitalize that h. I want to replace that character. Right? Well, we could go ahead and go sb.set character at. Right? Now, the first character should end up being H, capital H now. And let me print this out again to show you that it, in fact, is changed. It has been mutated. Right? It's not like a string that you cannot change. It has also, it has definitely been changed. Right? If you need to, you can also dump it to a string. Right? Dump a string builder to a string by simply going string message is equal to sb dot toString. And now once you've got that message, you can't change that message. The string builder is still mutable. It still exists. You can go back and change it all you want and then dump it to a different string instead. Right? But that's a mutable version of a string builder. Right? Just as the name implies, you can build a string, you know, make a little bit of changes, paint that wall over there or whatever, and do as many changes as you want. Okay? There we go. All right. So more string processing. More string processing. There we go. Formatting. In C, you can use PrintF to format the output to the standard output. You can use sprintf to print to a string in a formatted manner. Excuse me. Right. So what do you think that S stands for right in front of it? String, right? Let me go ahead and go over to the CS50 IDE here and show you what I mean. So if I were to just regular use printf, I could print an integer, double, I could print 3.14, 159, whatever, and a string char name is equal to Chris. There we go. If I wanted to print this to the standard output, I could use something like this. Printf, hello, name, your number is %d for the integer, and then pi is %f for the floating point number, right? And then end the line. And if I were to run this, I think this is main, so GCC demo. Oops, I never gave it inputs. This should be name, A, and B. There we go. And when I run this, then it's formatted, right? If you want to print that to a string, you can use the exact same formatting, exact same arguments, but instead use sprintf. You do have to provide it the string that you want to print to. So let me go ahead and go with a message here. I will make this into a string that is big enough to hold that message. 100, is that big enough? Okay. And GCC. Now if I run this again, you'll see that nothing has changed. That's because the printf is printing to the standard output. The sprintf has simply taken that formatting and dumped it into a null terminated string in message. If I were to actually print this out, printf message is equal to %s message, then you would see that it contains the same content. Hello, Chris, your number is 42, blah, 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 blah. Why did I get this extra end line right here? Yep, I printed a new line character to the string, and then I printed yet another new line character when I printed the string. So that's why I'm getting that extra one right there. Okay? sprintf if you want to print to a formatted string. Now again, with all the other string library functions in C, it's going to make an assumption that the message or whatever you're printing to is big enough to hold the result, right? And if it's not, then it's on you to fix that, okay? Let's see. Yeah, and then there's a common pattern that you can use with this. For example, if you wanted to format a string, but you didn't want to make an upfront guess as to, I made a guess that it would be at most 100 characters. What if that was wrong, right? Or what if I was wrong in the other direction, right? That it's not 100 characters. I'm wasting a lot of space, right? There's a common pattern that you can do to take a static string and use it as a temporary buffer, where you make it large enough to hold whatever you think that you might need. Overestimate. You way overestimate if you want to. Print that string to that temporary buffer, and then make a simple deep copy that is just big enough to hold whatever you're trying to do. For example, and I won't go through the full example here, I'll just cut and paste and show you. Here's a chunk of code here. Here's my first name and my last name. I'll go ahead and create a buffer that's big enough to hold both of those things. Big enough to hold any reasonably sized first name and last name. It doesn't matter, right? And then what I'll do is I'll use sprintf to print out my name in a formatted manner. Burke, comma, space, Chris. Right? I put that into the buffer, but I'm wasting a lot of space. There's no way that I need all 100 of those characters. 100 minus 1 because of the null terminating character. And so what I'll do then is I'll go ahead and create a new dynamically allocated string that is only just big enough to hold that formatted string. Why am I going +1 here again? Null terminating character, exactly. And then I will copy over into the full string, the buffer, and now I've solved this problem. I don't have to go through and count up how many characters do you actually need to do this. Just make a temporary buffer that's big enough, that's reasonably big enough. Right? Now if you're talking about megabytes of data, that's probably not reasonable anymore. Because this is statically allocated, it is on the stack, And if you exceed your stack space, then you will have stack overflow. So be careful. Oh, and then well, what about Java, the Java version of this? So how do I format in Java if I've got, say, A, B, and then a string over here? Not name, not char, star, whatever. String name is equal to Chris. How do I format this to the standard output? In the same way that I wanted to do it over here. System.out.printf. There we go. And run it, and it works. How do I do the same thing for a string? I could do that, but I wouldn't get this nice, you know, out to 6 decimal places or whatever. Out dot. Unfortunately, there is no sprintf. At least not where you think it is. But since we're dealing with strings, string dot, and unfortunately it's not printf because you're not actually printing anything. It's called format, right? And it's exactly the same as this. Come on. I've zoomed in too much. There we go. Now, remember that the string library returns a new string. So you actually have to capture that. String message is equal to, and then system.out.print, ln, say, message. And you can see that it's exactly the same string as before. Okay? So there's the Java version of that, that formatting. Java. I will format that as Java. There we go. Okay. Another operation is called string tokenization, tokenizing data. Right? So often data is formatted in a what's known as a flat file, or in particular a TSV file or a CSV file. We'll focus on CSV file. What is CSV file? What does CSV stand for? Does anybody know? Comma separated values, right? Now this is a flat file. If I've got data, for example, my name, my first name, my last name, my address, my NUID, whatever else other pieces of data that define me as a person, right? You need a way to delimit those. If you store that in a string, then you need a way to say that this is the first piece of data, this is the second piece of data, this is the third piece of data. With CSV files, the delimiter there is a comma. So first piece of data, comma, second piece of data, comma, dot, dot, dot. With a TSV file, what do you think the T stands for there? Tab separated values. And this is a common data format that you can even open up in Excel. If you have a CSV file, probably the default is to open it up in some sort of a Excel spreadsheet or number spreadsheet or something like that, right? And then you've got nice rows and columns in your data. This is a particular row, and each token is a column in that data. Okay? What I want to do is I want to process those token by token. I want to process it and get the first piece of data, Chris. I want to process it and get the second piece of data, third piece of data, fourth piece of data. And I want to define that by using some sort of delimiter. And in this case, it's going to be commas. Okay? This is called tokenization because each piece of data is called a token, and you want to split it up along all those delimiters and deal with each piece of data independently. In C, you can use a function called strtok, right? That's strtok, that splits a string into its separate tokens. Here is the full signature, and then we'll talk about each one of these pieces. So the first argument is the string of data you want to tokenize. The second argument is the delimiter or list of delimiters you want to use. So that second one is const, right? You're not going to change the delimiters. Who cares? It's a comma. But the first one is not const. What does that tell you about the first one? First argument is not const. What does that tell you about what the strtoke is going to do to your string? Strtoke, can it make changes? Yeah. Yes, so therefore it will make changes. Strtoke will make changes to your data. What it's going to do is it's going to go across the data, and the first delimiter it sees, it's going to put in a null terminating character. And then it ultimately returns a pointer to that token. Right? The return value is a pointer to a string that represents the next token. If you call this function once, you only get the first token. You have to call it over and over and over again to get the next token, the next token, the next token. Right? On the first call, you pass it the data you want to tokenize. It returns a pointer to the token. On each subsequent call, you pass in null to continue tokenizing the same data. If you pass in a new string for your first argument, it will restart the tokenization process. Because it doesn't know the difference between, I want to tokenize that string. Okay, now I'm done. I want to tokenize that string. You have to give it a string to tokenize. If you don't give it a string to tokenize, it will simply continue operating on the same string. Right? And that's how you tell it to continue operating on that string. How do you know when it's done? So here's the first token, Chris. Second token, Burke. My NUID. City. State. My office number. I don't think that's my office number. I think I don't look at the numbers. I think I'm on 105. Right? Doesn't matter. It's closed to the public anyway. Right? 105 Shore. How do you know that when you get to the end? Remember, it returns a pointer to each one of these tokens. So to give you a pointer that tells you I'm done, there is nothing left to tokenize, what could it return? Could it return a valid pointer? No, because that would be the next token. So how does it tell you that there are no more tokens? It returns null. It will return null when there are no more tokens available. Right? All right, so let's go through a demonstration here. In fact, I'm going to take the same data that we were just working with and put it into a string. Not that we were working with, but that I displayed up there. Right? So here is char data, I guess. There's my data. I want to tokenize it. Okay? I'm going to call strtoke. And the first time that I call it, I'm going to pass it in data. What token do you want to use? Well, it's clearly CSV data, so the token should be comma. Now I want to print that token. PrintF token equals %s. Except what's the problem? What are you printing? I need to capture the returned value, char star token. Remember, it returns a pointer to the next token. Let's go ahead and compile this and see that it actually works. Oops, well, no question marks anymore, token. There we go. There's the first token. Let me get the second token, my last name. Well, I can't have two variables named token, so only the first time will I declare it. Let's try this one. Let's try doing it like this. What's going to happen though? It's going to print Chris and then Chris again. Why? Because I gave it the same string. It's basically I told it, go ahead and start over at the beginning again. Tokenize Chris, tokenize Chris, tokenize Chris. Right? Each subsequent call, I need to tell it, continue on the same string. Don't start at the beginning of this string. Start at the next token. Then start at the next token. Then start at the next token. And to do that, you pass in null for the first argument instead. Cut, paste, cut, paste, cut, paste. This will end up printing, I do it 4 times here, right? So Chris, Burke, then my NUID, and then Omaha. All right? That seems like a good pattern to follow, right? Cut, paste, cut, paste, cut, paste, cut, paste. Should I have continued doing that? Probably not. What's this going to, because I did it too many times, what's it going to end up printing? Null, null, null. Why? Because there were no more tokens. Right? Once it got to the end of that data, my office number, then it continued to, I said, continue tokenizing. Okay, well, here you go. There's nothing left to tokenize. Here's null, right? Null, 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 null. Not only that, but do you want to do something like this? Cut, paste, cut, paste, cut, paste? Probably not. So let's go ahead and reverse this and rethink it. What should I be doing instead? A loop, right? Now, if I know how many tokens I expect up front, then a for loop is perfectly valid, right? I know that there are going to be 5 tokens. Well, then go ahead and do this 5 times. You've got to be careful, though. If it's malformed data and there were only 4 tokens, right? Or if there were 6 tokens, right? Or there were 7 tokens, then that's a way that you can detect bad data. Right? Detect bad data. Once you've got bad data, error handling, I don't know what to do anymore, we quit or something like that. Right? But suppose I don't know how many tokens there are up front. If I don't know up front how many tokens there are, what should I use instead of a for loop? Let's use a while loop instead. Okay? So while some condition, I will tokenize, I'll print the token. Actually, I'll tokenize and then I'll print the token as my first attempt. Right. Now, what's the condition here? Well, token is not equal to null. I called it the first time up here. That gave me a valid token, Chris. And I will tokenize it again, token, 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 until it gets to the end, at which point there are no more tokens and it returns null. And I break out of this loop. Okay? Will this work? Let's find out. Well, I skipped the first token. Why? Token, and then I immediately tokened the next token. So I should have printed this first. Right? Let's fix that. And by the way, I was off by 1 on the other end because I was off by 1 on the front end. So this should actually fix both of them. There we go. And I've tokenized the entire piece of data here. Now, again, if you want to, you can go ahead and keep a counter. Int num tokens, right? 0. And I will go ahead and increment this every single time I print something. Num tokens, tokens, plus plus. And then I can do some error checking. If I break out of this loop and it's less than the number I expected or greater than the number I expected, then I can go ahead and issue an error message or quit or do whatever, right? So to do, check that num tokens is correct. Here I'll just print it out though. Num tokens is equal to %d and the line num tokens. How many would you expect here? 1, 2, 3, 4, 5, 6. Right? So is it correct? Yay, it is. Now let me show you some variations here. What if I changed my delimiter? What if I changed it to a lowercase o? How many tokens would you expect now? Let's walk through this. Where's that first lowercase o? Right there. So it would be Chris, comma, B, and then the rest of it. And by the way, was the comma ever included in my tokens? Nope, that's my delimiter. It chops it up and throws that away. So let's see what this looks like. Right there, only 3 tokens. The O in Shore was the second token. What if I change this to a capital O? Actually, let me show you at the same time. You can use combinations of delimiters. So, right? There we go. It will chop it on a uppercase O or a lowercase o or a comma. Now there are going to be a lot of tokens here. Again, walking through this. Chris, comma, that's why we went to the next token. B, lowercase o, that's why we went into the next token, Burke, comma, my NUID, big O Omaha, that was another one. And by the way, that there were two of them, right, in succession. Comma, and then a big O. What was in between them? Nothing, so nothing got included. Right? Empty tokens are ignored, okay? Let me go ahead and restore this to what it usually is, though, okay? So tokenization and processing CSV data, okay? So there we go. Questions on tokenization so far? Yeah, go ahead. Ooh, using str token? No. It's single characters only. So the question was, could I define an entire word to be my delimiter? Like HELLO, that's my delimiter, not just one single comma. And unfortunately, no, I think that if you went with OUR and OUR, it's going to treat that each one of those things as a delimiter. Yeah. Otherwise, you can see it here, R in my name, that was treated as a delimiter. You might, let's try this. You probably have to come up with some sort of regular expression. Yeah, it's not that simple. You definitely want a regular expression. Now Java, that's a different story. Let's take a look at Java. So let's go ahead and change this over here in Java. Java, it's way easier. So this is going to be a string of data. And now I don't need to use a function strtoke at all. I can do this with one line of code. So data dot. Now the act of tokenizing it is basically chopping it up, or taking a string and splitting it into multiple strings. And that's what Java calls it, split. So if you want to split all this data on a single comma, you can. What it does is it returns an array, a regular old array, unfortunately, of data, tokens. There we go. And I could go ahead and iterate through that array. So for string token in tokens, I will go ahead and system.out.println token. No while loop required here at all. Once it gives you an array, you can go, of course, tokens.length and get the number of tokens that you actually split it into. And run this and see it's much easier. Right. Yeah?
But this one also doesn't change anything to the original.
This one can't, because strings are immutable. Right? So yes, the original data here is not changed, because you can't change it. The only way that you can change it is by reassigning the actual variable. Data is equal to foo. Excuse me. Now what happens when we tokenize foo? Nothing, it's just foo. Right? There we go. All right. Now back to your question of how could I tokenize, say, on multiple things. So let's go ahead and go with comma, O, or big O, little o, or a comma. That's actually the default. It's not going to treat each one of those things as an individual character. At no point did capital O, lowercase o, and then comma appear in my data. So that's not going to, there were no delimiters at all. It treats it all as one thing. Right? Now, here you can use full regular expressions. If you want to, you can go ahead and go with O, or this, and then put it into a bracket, I believe. And this is just me remembering off the top of my head how to do this. There we go. Now we get the same behavior as before. By putting it into square brackets, it forces it to become what's called a group in a regular expression. The first character, or the second character, or the third character. You can also use ranges, 0 through 9. And what will that do? That'll split it up even further here. Whole bunch of empty tokens, by the way, because each one of these numbers was split up. Each one of these individual numbers was a single token. Right? If you want to, you can go ahead and make combinations. So here, any three, actually I'll go 4. I don't like that. 9, there we go. Now I can cut and paste. Now what I've done here is I've said any number 0 through 9, followed by any number 0 through 9, any number 0 through 9, any number 0 through 9. In other words, 4 numbers in a row, 4 numbers right next to each other. Now what this is going to do is, this is going to be a token, 3514. This is going to be a token, but is this going to be a token? Nope, because it's 3. And you can see that it's not split here. Right? Regular expressions are extremely, extremely powerful. You can do a lot of stuff with regular expressions like this. You can go with ranges of A to Z, but not uppercase. Now it's really screwed up. Right? But NE was not split up. You can go with just uppercase, A through Z. Any A through Z. Right? And now it's only uppercase letters, single uppercase letters that are the delimiters. If I wanted to only split on NE, I could do that. Any combination of 2 uppercase letters. And now it's only NE that becomes my delimiter.
Is that following ASCII code?
You can do Unicode, but ooh.
So like if you did like lowercase a to z, would that work?
Smile emoji. I don't want to get into this, but let's go ahead and try it, I guess. Because it's kind of fun, I guess. Come on. All right. Can I copy you? Nope. All right. This is not going to let me copy these. Oh, okay. There. Copied. There. Okay. I will go ahead and put this into my data right here, and then I'll use that as my delimiter. Hey, it worked. Stupid, but okay. You'd probably want to escape that stuff out with actual Unicode escape sequences instead, though. Does that answer your question, or?
Yeah, I was just wondering like if it like kept track of the order.
It does. So Z through A. I'm not sure what that would do. Let's find out. Probably this. No, that's an illegal pattern. You can't go backwards. You got to go forward. But you can do something like, well, element O and OP, so O through Z, right? You can do a subset of them so that this will no longer recognize NE because I've excluded N on the front end. Right? There. So it's the entire data now. You can also do things like any white space characters. B. There we go. Nope, that's not Java white space regular expression. I forget what it is. S. There we go. So S. So usually it's /S, but /S, backslash is a special character, right? So to escape the backslash, I have to have 2 backslashes here. And this will only end up splitting on this space right here in shore. Right, there we go. But if I added a bunch of other things like an n-line character, a tab, an actual space, all of those are white space characters. And so that's a single white space character. If I wanted to, I could go with 2 white space characters right after each other. There we go. And are there any such in that data? Space, and then a white space character, then another white space character? No. Is there? Shouldn't be. No, there's not. That's the actual tab right there. Right? And then it went to the next line. It's not actually splitting on those, right? So it looks bad, but whatever. Right? Here, I'll show you. It's not actually splitting on that. Okay? But if I put 2 of them in, 2 tabs, then it definitely would split on those things. Right? So regular expressions are extremely powerful. It goes beyond the scope of what we're doing here. I'm just giving you a taste of it. but you can do a hell of a lot. You can say one or more, right? You can say two or more. You can say exactly three or more, etc. You can add, a star on it. So zero, A through Z, star. What that will do is it will, here, let me change it to lowercase, A through Z, so it actually does something. Any characters where there are 0 or more appearances of it, what this is going to end up doing is it's going to end up treating every sequence of lowercase letters as a delimiter. Right? And you don't get any lowercase letters here at all anymore. It's going to treat this entire sequence right here as a delimiter. This entire sequence, this entire sequence, and then this entire sequence. Oh, and then, I'm sorry, it's 0 or more. So it's actually treating empty strings as delimiters as well. So this is 1 or more. And there, now I get the behavior that I wanted. Yeah.
So if you want to split everything, no matter what it is, you just...
Oh, you could split. Just give it an empty string.
Okay.
And now this will be every single character, I believe. Yep. Where's dot, 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 dot. Although you could do that just by iterating over the character, like, right? So, but if you really wanted to split it along all those things, you could. All right? All right. So very, very powerful stuff here. And with great power comes great responsibility, right? So Java, use the string.split method. You can use regular expressions to do some really powerful stuff. All right. Hello to random people online. I don't know. I don't know if people actually find my streams or if they're just bots or something like that. Yeah, go ahead.
I just really quick wanted to, I guess I'd never really known what in our Java for loop, what is the logical comparison saying? So there's a colon.
Oh,
I kind of
this thing right here?
Yeah.
That's just the syntax. The way that you read this is for each, but you don't use the for each keyword. Some languages do have the for each keyword, but not Java. For each string token in the, that's how you read the colon, in the collection tokens.
Okay.
Right? And then token is updated on every single iteration here automatically for you.
Okay.
Yeah.
When we do like A through Z, and they're saying that look for a letter and if that letter, if the letter basically split it there.
Split it there, yep. Any uppercase A through Z. If you wanted any uppercase and lowercase, you could combine them. You could combine 0 through 9, or 0 through 9. Now this is any alphanumeric character. And I'll end up only getting the punctuation characters now at this point, right? Yeah. 1 or more? 1 or more. There we go. And I'm just getting a bunch of, get the exact opposite of what we started out with, right? Instead of comma delimited values, now I'm just getting the delimiters. Yeah. Plus is for 1 or more occurrences. If you just go like this is exactly 1 occurrence. This is 1 or more occurrence, because if I did this, then I would just end up getting a bunch of empty tokens. Right? Because it would split on C, and then it would split on H, then it would split on R, then it would split on I. But if I'm saying 1 or more, then that means there's 1 and there's more, and that's the entire delimiter. Right? This is 0 or more, so even an empty string will match this, and that'll end up being a delimiter, and that's how we got every single character as its own token. So lots of really, really powerful stuff here. Yeah?
The reason that they're going to the next line is because you're doing print now.
Yes.
If you just print the token,
Yep.
it would be,
Yeah, I mean,
that would be gone.
maybe it would have been better to be explicit about that and surround it with printable characters so that you know exactly what the tokens are. So let's go ahead and do that again, maybe with, I don't know, A through Z. There we go. And you can see that some of these are, a lot of these are going to end up being empty tokens. There's an empty token, there's an empty token, there's an empty H, R, I, right? cetera, et cetera.
So when you print it, there would be no space and there would just,
Yeah, because it's an empty token.
oh,
And so you can't have empty token. So you can check for that. We can go ahead and ignore empty tokens. How? If the token is empty, is blank or is empty. Is blank means that it's going to have a bunch of white space in there, right? But is empty means that it is of length 0. If it's empty, then ignore it. Right? Else, so if it's not empty, then print it. And only if it's not empty, print it. And now I end up ignoring all of those tokens that are empty. Dot is empty is a very nice and handy thing to do. You can also use is blank. If you want to ignore the white space, then you can do that as well. Yeah,
Is empty only for token or can you use it for string?
it's for any string because token is a string. Right. It's any string. Right? And again, if you look at Java string, there are RTM, read the documentation. There are dozens and dozens and dozens of functions that you can use. Right? I think that you'll find, especially in your hack, that a lot of the stuff that you're going to end up doing in the C version, where you're rolling your own solution, there's something to do it for you in Java. Right? And it's going to be a one-liner. Yeah?
can you split it without saving something out?
Retain the delimiters. Java split retain delimiters. That might be ambiguous because if here's a delimiter, here's the first token, second token. Do you want it on the first token or do you want to retain it on the second token? And retain the delimiters. Good question. We'll give you the desired array only with the empty item first. Dot dot dot. All right. Yes. This is yet another grouping. So the parentheses is a grouping that remembers the grouping. Right. So let's bring this over here, and here's our example. And I think that if we could adapt this for commas by going like this, but I end up not printing it because it's empty. So let's go ahead and get rid of this maybe, and unconditionally print them. And I believe, nope. So maybe I do need that question mark equals. Nope. Okay, I'd have to read more documentation to understand, but the regular expressions in general, you can remember your token that that matches it by putting it into a group like this, with the parentheses instead of the square brackets. And then I'm at the end of my limit. This is curly brackets, this is square brackets, and then this is parentheses. Right? Best as I can until arthritis takes over, and then I can never do anything like that again. Right. Hopefully arthritis doesn't take over. Right. All right, so the last thing I would cover is string comparisons, because we already previewed this a while ago. But in C, in neither language, can you use the equals equals operator to compare strings. Right. In both languages, the equals equals operator compares memory addresses. Right. So if this string is the same thing as that string in memory, if only then does it say true. Right. Let me show you a demonstration over here in Java just to get an idea what I'm talking about here. String A is equal to hello. Right. String B is equal to hello. I'm going to force it to actually create a new string here. New string. Otherwise, the compiler will compile away this inefficiency of creating two strings with exactly the same content. There we go. And let's go ahead and try to write a conditional using those equals equals. If A is equal to B, then print system.out.println equals. Right. Now, is this going to print out equal? Nope, it doesn't, because they're not equal. The contents are the same, but that A is pointing to some location in memory, B is pointing to a different location in memory, and so those are not the same memory addresses. Exact same situation as in C. Right? So what I want to do is I want to actually compare the contents of those of those strings. I do want to get that these two strings are equal. Right? So how do I do that in C, first of all? In C, you can use str CMP. What do you think the CMP stands for? Obviously, str stands for string. CMP is going to be compare, right? To compare the contents of two strings. This is what's called a comparator pattern. So I don't know. I said the other day that the comparator was not a real word, excuse me. Let's ask Webster. Yeah, go ahead.
So why would the equals operator work ever, I guess, if we have like two variables A and B that are both equal to 10 and comparing memory addresses? Are they just compiled to be the same?
Oh, in Java, yes. They would say, wait, you've got two strings here with hello in it? I'm not going to do that. I'm going to create one string and then make it point to these two because it is immutable. You can't change it, so why have two copies? I tricked it by explicitly invoking the constructor, which forces it to create a new string somewhere else in memory. Apparently, it is a real word, excuse me. Any various instruments for making comparisons as length, distances, tints, etc. Okay, so it is a real word. I thought it was us computer scientists making up words. A comparison, all right, well, what is the noun form of a comparison thing? A comparator, right? So a comparator pattern. It takes two arguments, A and B. Right? It returns something negative if A comes before B. It returns something positive if A comes after B, or B comes before A. It returns 0 if they are equal. And I'll put equal into double quotes here because the contents is what we were talking about now. Are the contents equal? Okay? This is a comparator pattern. You will find this all over the place. It is so ingrained in programming languages that it's a standard. In fact, when we get to searching and sorting, you'll be writing your own comparators. So you don't have to rewrite code. All you have to do is write a new comparator. They go like this, they're out of order, or they are equal. The way that you remember this is A, B. If A comes before B, you're on this side of the number line, negatives. If A comes after B, you're on this side of the number line, positives. If they're equal, you're right in the middle at the y-axis, 0. So order, in order, out of order, equal. Yeah?
When you say A comes before B, is that the ASCII?
That's a good question. That's what we're going to play around with now, right? So strcmp uses what's called lexicographic order. Lexicographic order is not dictionary order. It is ASCII text table order. And it returns something positive, something negative, or 0, depending on the relative ordering of those. Let's go over here to our CS50 IDE. Get rid of all this garbage. And let's go ahead and create some strings and start playing around with this. Char A is equal to apple. Char B is equal to banana. What comes first, apples or bananas? Apples, right? strcmp, A and B. I'm giving it A and B. Are they in order? In other words, it will return something 0. PrintF. %s comes before %s and the line, A and B. Else if strcmp of A and B if it's greater than 0, then they are out of order. And so I would print out that B comes before A. Else, what's the only other case here? They're equal. So, oops. S and S are equal. Right? So what's it going to print in this case? Which comes first, apple or banana? Apple comes before banana. Which comes first, apple or banana, a proper banana. Banana comes before apple. Why? Think about the ASCII text table. How is it set out? Capital letters, A through Z, lowercase letters, A through Z. So capital B comes before lowercase a. That's why we call it lexicographic ordering. It is not alphabetic ordering. Right? It's not dictionary ordering. It is not alphabetic ordering. In the dictionary, all the lowercase a's and all the uppercase a's are right there in order for you. Yeah.
So when it's comparing it, is it comparing the first letter?
Yep, it looks at the first letter, and if they're equal, like say apple and apples, right? Equal, 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 until it gets down to the last letter here. Now what does it compare? Nothing, the null terminating character versus S. Which one of these things comes first? Apple or apples? Apple. Why? Because it's the shorter. Right? If they are the same thing, then they are equal. Oops. They're equal. But again, if you're using banana, bandana, right, that's going to come first because of the ASCII text table. Right? Yeah.
Or what if like the last, it's banana, but only the last A is capitalized? Would that still come through?
Okay, like that. Let's find out. What comes first now? Guess. Apple, because it finds the difference in the first character. Right? And it stops. Right? It keeps going as long as they're equal until it finds a difference and says, okay, this one comes first or this one comes first. Right? And it works with numbers too. 123 and 9. Which one comes first? 123. Why? Because it's a string. It is not a number. It's lexicographic ordering. It's not integer ordering. Obviously, if you were doing this as an integer, 9 would come before 123. But because 1 comes before 9 in the ASCII text table, you have this behavior. Okay? Exact same thing in Java. Let me go ahead and translate this over in Java. Well, first of all, A and B. There we go. Apple and apples. Or apple. There we go. I don't have strcmp. Instead, what I do is I have a string, and I want to compare it to another string, B. A, compare that to B. A, compare to B. And otherwise, they're equal. And then, of course, system.out. Okay, system.out.printf, printf, and printf. Now, which one comes first here? Big Apple, there we go, yeah. Oh, what's wrong? Okay, I misspelled compare. There we go. Compare to. Big A apple comes before little a apple. Exact same comparison. But here you can use emojis. There's one emoji. And here, strong arm man. Which one comes first? Does it matter? I'm sure that there's some number in the Unicode table and some other number in the Unicode table. One of these comes before the other one. I have no idea what it would be. Right? Okay. Strength comes before sleepiness or whatever this is supposed to be. Right? Then, of course, you can play around with these strings. But anyway, so it's lexicographically. If you don't care about case, in C, you can use strcasecmp, which ignores the case. It's weird because if there's case in the name, it tells me that it should be case sensitive, but it's not. It's just the opposite. It ignores lowercase and uppercase respectively. You also have strncmp and strncasecmp, which only compare a limited number of bytes. So if you only want to look at the first 3, right, maybe for your for some of your upcoming hacks, you can use strncmp instead. Does it match in the first 3 characters? Right? If so, then they're equal or something. Here's our full demonstration here that we did. And in Java, you use string a.compare to b. There is no CMP. There's just one string, you compare it to another string. If you swap those strings around, of course, you're going to get opposite values. Do not read anything into the actual number. It returns, again, to review, it returns something negative. It returns something positive. With strcmp, there is nothing in the standard that says anything about the magnitude of that number, just its sign, positive, negative, or 0. In Java, you can read something into it. I believe that it gives you, I forget, we're going to have to look it up. Compare to. There we go. Lots of stuff to read here. Compares two strings lexicographically based on Unicode. All right, you just have to read it. Here, let k be the smallest such index whose characterization k is a smaller value, blah, blah, blah. So it does give you some information with the magnitude of that number, okay? But not in C. In C, you can't read anything into that number at all. Basically, in Java, you could use that number that it returns, negative or positive, to determine where's the first place that it differs. Yeah?
So is it, in C, is it just a random negative number?
Yeah, unfortunately. Well, if you look at the actual implementation, I'm sure that there's some rhyme and reason to it, but there's nothing in the standard that says that there has to be a rhyme or reason to it, so you cannot rely on it. All right? And then you can rewrite it yourself and have a different rhyme and reason. You can rewrite it so that you randomly generate some number and then make it the sign correct, and then you're screwing everybody up that made an assumption about it. Right. All right. More on strings. Okay. String tokenization, et cetera, et cetera. So there's an example in Java. If you want a case-insensitive version in Java, it's compare to, and this one makes a little bit more sense, ignore case. And what about byte-limited versions? Just create a substring. So in C, or in Java, excuse me, is there a way that you can have a substring? Absolutely. In fact, there are several ways that you can have a substring. Come on. Find substring. There we go. You can have a substring beginning at a certain index and going all the way to the end of the string, or you can have a substring that begins at a certain index and ends at a certain index. Backtrack one because it's exclusive. So that the returns a new string such that it starts at begin index and extends to n index minus 1, so that it always has n index minus begin index length, right, guaranteed. Strong hint for your hack this week. Right? Use what tools you have available to you. All right. Any questions? Otherwise, we breeze through that. What we'll do next time is debugging. I'm going to demonstrate a whole bunch of debuggers. First of all, over here in the CS50 IDE, you might have noticed this little thing over here called, what is this? Debugger, right? How can you use that? How can you use a better debugger called GDB? And then over here in Eclipse, how can you use its debugger? It's this little thing up here. That little icon is a bug, and you can run it and debug your programs. But that means to properly use a debugger, you have to have a reproducible problem on your own computer. Right? You can't just put it into the web grader. Everything looks great here. Put it in the web grader. Oh, it fails 50 test cases. But it's not failing any of my test cases. You need it to get to fail one of your test cases. Once you've got it to fail one of your test cases, that's when you can fire up your debugger and find out what's going on. What's wrong with this thing? Right? Go line by line until you find out what's going on. Right? If you run valgrind and it tells you that it died at line 12, you can fire up your debugger and run your program up to line 12 and then look and see what's going on. What are the variables that I have? Right? And why is it failing? I'll show you, I'll demonstrate all those tools next time. Otherwise, remember that you do have your midterm 1 week from tomorrow. It's asynchronous in that it'll open up. There's no lab next week. It'll open up midnight, and you'll have all the way till midnight to complete it. I'm in the process of writing it, but whatever time we have left over on Thursday, I can go over a previous midterm if you want. What?
Is it like questions or
No, it's code. Write this program, write this function. Right. So it's basically the same thing as a hacks. In fact, that's what the survey, one of the surveys that we gave to you at the beginning of the semester is kind of a study in, do you like that format, or do you want, or do students want multiple choice coding questions? It's kind of icky in my opinion, like, what? You're coding, why would you want a multiple choice question about code, right? Next one?
Yeah, so
Go ahead.
are we gonna take this like on our personal computers, or we're
You can
gonna-
take it wherever you want. Yep. Just know you can't collaborate with anybody. Yep.
Like, search it up if you forget the manual or something.
Absolutely. That's what coding's all about. RTM, go back to your notes, open book, open note, open computer, closed people, right? So no collaboration with anybody in here, no collaboration with a friend at home who's had 50 years of Java experience, which is not possible. No collaboration with, hireacoder.com, etc. Yeah.
Is it expected to take around the same time as the lab?
The lab, probably not. I mean, it's designed maybe for an hour and a half.
Okay.
If you know what you're doing, I should say. It's going to be worth, I forget, 150 points. So it is going to be a little bit longer than than the main sections exam, because of course you say that you have 2 exercises, right? You could do one in Java, do one in C, and now your choice, do a third program, either or, in the other language that you didn't do. So it's going to be a little bit longer, but again, you'll have 24 hours to work on it. If you want to work right at midnight, I would not recommend working right at midnight of the deadline, but whatever 24-hour period. If you want to take the entire 24 hours, go ahead, I guess, but it shouldn't take you that long. Right? If you find yourself taking 24 hours to do that exam, you're probably not going to do that well. Yeah.
So it's in both languages?
Yeah, there will be exercises in both languages, yeah.
Any questions to Elise in class?
Any what? Oh, yeah, you can feel free to ask questions to LAs or on Piazza. Don't post code, of course. But understand that we'll also not give you the same level of answer that we would on a hack. Yeah.
Will there be a one period for testing?
Oh, yeah. I'm not grading this crap manually. I don't grade for this section anyway, but I grade for the main section, and you better believe. I do grade every single lab, and unfortunately, there's no for my CS2 course. I got so sick of it last year that I just automated it through JUnit. So all I have to do is hit one button, and I don't even have to enter gradebook grades anymore. That's my dream for next year for labs, because I do have to go through 120 goddamn labs and grade them all. I will be automating that at my first possible convenience.
Do you, links into Canvas
No, it just dumps a CSV file, which I upload to Canvas, and then I'm done. That's why we code, to automate this mundane, data entry kind of stuff.
Do you have to like actually look at the code for each lab?
I do take a cursory look, just make sure that, because especially you'll find this is true, that if you with any endeavor, if you hand send something perfect, right, nobody's going to be digging in the dirt for flaws. So if it passes 100% on their web grader with input and output, I generally don't even bother looking at the code, because it's got to be correct. But if it does fail, then I start looking at it so that I can give partial credit or some points or something like that. And if I see nothing is implemented and they were just the original files, obviously, no, 0. But if I see some effort there and something that looks like it's right, then I'll try to give partial credit for it. And that's why I hate giving partial credit, because that's the most work. And that's why in the future this is going to be automated. No way. I've been doing this too long. I'm done.
The other Mac?
Oh, yes, that's why I was kind of, came early and did a little bit of troubleshooting because it is a new OBS as well. So the setup of pushing out a new stream is completely different. And it's been working for the first 2 days, so it should be working forever. We were at 2,500 kbps on the stream, but now we're at like over 9,000. So,
Oh, wow.
so I don't know if I don't know if anybody watches the streams, if they're grainy or not, but certainly they're going to be way less grainy now because it's like triple the throughput that I'm used to here.
Is that ARM based now?
No, unfortunately, this is i9. So the M2, M1Xs or M2s aren't released yet. I just had to bite the bullet and tell the department to give me a new one because I finally got a keyboard that works.
Oh,
Right.
oh, they get it from school.
Yeah, yeah. I will be getting one when the M1Xs come out, though. Okay. Then I'll see you on Thursday for some tooling demonstrations.